Okay, today we'll be starting limits. So that little video clip was to kind of give you an introduction about limits. Okay. I'm going to explain limits a variety of ways, like kind of thinking real world out there, something that you can associate it with, attach it to so that it's not some arbitrary thing or just math floating out there. So, see this dotted line? We're going to say that that's the terminal at the airport. You know, the long hallways and then there's all those gates off of it. Okay? I spoke about this when we started Peacewise, and I told you to jot it down, but you may or may not have. Okay? So, this is also my fence from Peacewise. How would you describe all the numbers on this side on this side? Okay, less than. What else would you describe if it was a number line? What type of numbers are over there? Negative. Okay? So, this has a negative exponent. Okay? So I want the numbers. Now, it doesn't necessarily go with negative numbers because it's not always negative numbers on the left, but negative goes with left. Negative is left-hand side, okay? If negative is left-hand side, then positive is right-hand side, okay? So it's the direction that you come at, okay? It's that side of the fence. So in terms of my little story about the airport, okay, let's say that I'm flying in from Baltimore. What gate am I at? 1.3, okay? And was I on the right side of the fence or the left side of the fence? The right side. So that's going to be the plus. So this is plus, this is negative side of the fence, okay? So I am at 1.3 when I'm at the right side of the fence, okay? My sis, yes. No. This, just this intro, you don't, the rest you have. Okay. All right. My sister is flying in from California. What gate is she at? She's at 3.8, and she came in from the negative side, the left-hand side, 3.8. Are we going to meet up at the airport? No. We're not going to meet up at the airport because we're at different gates. Okay? So, if we don't meet up, the limit does not exist. Can someone tell me what type of discontinuity is in the picture up there? A jump, okay? Jumps never have limits. Let me rephrase. Jumps never have limits at that exact value, okay? Okay? Good? All right. Yes? Okay, so the key piece that you want to write down on that paper is that if the exponent's negative, I'm coming from the left-hand side, and where it touches the fence, okay, my wall, and if it's a plus, I'm traveling from the right-hand side. Good? Okay. All right. This you do have if you will turn one page past the page that I told you to be on. You go one page. Should be the next page. Everyone with me? Okay. So, all right. You have 1 minute to tell me the locations of all the discontinuities in this picture and what type of discontinuity it is. Begin. Okay, so where's the first place there's a disconnect? What value? At -2, right here, yes? And what type of discontinuity is that? It is a jump, okay? And the next type of discontinuity? At where? At 2. And what type is that? It is an asymptote, but that is not the name of the discontinuity. Infinite. I understand that. I don't make the rules or the vocabulary. It's called infinite because they're headed towards infinity. Okay? All right. What's the last one? 4. And what type is that? Removable. Now, I slip up sometimes and I use the elementary vocabulary, which is a hole. Okay, it's a hole in the graph. You should really use removable. Okay, so you can yell at me every time I slip up and say hole. You can say it's removable. Use proper vocabulary. Cool? We good? Just a quick review. Now we're going to put it together. We're going to put piecewise together, this vocabulary together. We're going to do limits. Okay? All right. So it wouldn't be a worksheet if there weren't typos. If you look at your worksheet, you're missing one column, okay? So it should go on your paper. It goes, it should go negative, positive, and then you guys need to add this last column. It got left off. So I marked the typos. So make it a negative. I made both. I accidentally hit the plus when I was typing it. Okay. All right. So to do this problem, let me move this out of the way. This is the picture. Now, you have it on your paper. This was from the previous screen, okay? I just have it shrunk down so that we can see it. I'm going to highlight while you guys are writing this down. I'm going to go ahead and highlight each of our fences. Okay, just like when we were doing piecewise, we did the fences because we need to know who owns what. And just so our discussion is a little bit better, and because I didn't do it this way in previous years, but I did it today in third period and they found it very helpful, so that's what I'm going to do. I'm going to color code, oops, wrong thing. I'm going to color code stuff to make our conversations a little bit easier and solidify what we're talking about. Okay. Oh no, I already used that color, so purple. Oh, I could have used green. You're right. I did orange. Sorry. Okay, are we good? So I color coded so our discussion's easier. This base number here, the base, is your fence. So which color fence am I looking at? I am looking at the orange fence right here. Yes? Orange fence. Okay? It has a negative, right? So do I want to be looking to the left of the fence or the right of the fence? Left. So when I travel on the left, is that red or blue? Red. Where does the red graph touch the fence? It touches it where? So this is an input, so I need a output. Output is which variable? Y. So I need the Y value. What's the Y value? We're going to talk about that in a second. Where does it touch? At 1. So, without me saying any names, just because this gets put on YouTube, sorry. A student just asked, but there's a hole there, like it's not equal to. So there is a difference. A limit is what value is it approaching, okay? So a limit is approaching something. It gets very, very close. It is not it's not value. There's not a value. So the limit exists there. The value does not, because it's not included. It's an open circle. Okay? And that's going to be important, very important in a second. Okay, so here I am right here. Am I going to look to the right or the left? To the right side of which fence? I'm still at the orange fence on the right side. What color is that? Blue. Where does the blue meet the orange fence? At 4. Are these two in agreement? No. Therefore, because these two are not in agreement, my limit at exactly -2 does not exist. They're not going to meet up. They don't match, so the limit at that point would not exist, because I'm not going to duke it out and find out who really gets the answer. Okay? All right. Would you please try the next two rows on your own, and we're going to go over the answers or what you came up with. Okay, before I go over the answers, I'd like to re-summarize. When you're coming up for the limit, okay, you want to know where the left or the right side of the picture touches the fence, not where it's drifting off to. So I don't care about the other end. I only care where the graph touches the fence, okay? All right? So in this case, my fence is at 2, so I'm looking at the green fence. All right? I want to know the negative, so I want to know which side. The left. Which graph is on the left? What color? Blue. So when blue approaches that green fence, as blue is traveling, when it gets to the green fence, what is its height? Positive infinity. Yes. Okay? Now, there's a plus. So which side of the fence do I want? Right side. So which color picture up there? I'm looking at the purple function. Here's the purple function. I want to know what its value is when it touches what? The green fence. So here it's touching the green fence. What's the value? Infinity. Positive infinity. Are they in agreement? Okay, so this is a tricky one. All right. If one was going to positive and one was going to negative, it definitely does not exist. This is one where I could go either way. You can go ahead and say positive infinity because that's not really a value. You can say does not exist because infinity is not a clear value, okay? If you were to put positive infinity, I'm going to accept it because it's not a true value. But this one does not exist, okay? Because I can't pinpoint infinity, okay? And it definitely does not exist if one's going to positive and one's going to negative. If you put positive infinity, I would let it slide because maybe they do meet up at infinity, okay? All right. Which color? All right. I'm going to point to you because I don't want to say your name so it doesn't happen. I'm going to help you get through this one, okay? All right. What number fence do I want? 4. Which color fence is that? Yellow. So up here in the exponent's negative. So do I want the left or the right? Left. So here's the yellow fence. Which function is on the left-hand side, purple or red? Or sorry, orange. Purple or orange? Purple. Purple. When purple meets yellow fence, what's the height of the graph? Right here where they meet. What's the height? 1. Good? Yes? If you don't see it, okay, you're good? Okay, so see the purple function? It runs into the yellow fence at what height? 1. Because we're looking for output. Output's always height. Yes. Okay, so if I'm on the orange line, it is 1. Are they in agreement? So what is the limit as it approaches 4? 1. Now, you might want to argue because you're like, there's a hole there. It's removable. Listen, the limit exists at that point. The limit, because limit is what am I approaching? What am I headed toward? The value does not. Okay? So, if I were to ask f of 4, if I were to ask f of 4, when x is exactly 4, is there an answer? No. This would be does not exist because there is a hole in the graph. The limit exists, the value does not. Cool? Okay. This one you don't have. I don't know why. You should have this one. and 2 others on the back of your paper. I'm going to give you 2 to 3 minutes to do the limit questions, please, and we'll go over the answers. Good? All right. All right, we are back. First of all, before I even begin, because this also helps you determine the overall limit. This is a picture of what type of discontinuity? Infinite. Okay? This number tells me what? What does that number tell me? It tells me where to put my fence. So here's my fence at 1. Yes? Okay, so I'm going to have a red function and I'm going to have a green function. Okay, cool? All right, so positive. Do I want the function on the right of the fence or the left of the fence? What color is that? Green. So when my green function is getting to my purple fence, what value am I at? Positive infinity, because it's going to keep going and going. So the negative is the left, which is the red function. So the red function touches the fence at what value? Negative infinity. Are these two in agreement? So therefore, at exactly, because there's no exponent, at exactly 1, the limit does not exist. Cool? All right, can I move on? All right. Okay, what type of discontinuity? Removable. Removable. Okay, where am I going to put my fence? At positive 1. Thank you. All right, let me go back. I have a green function. I have a red function. Okay, so positive. Positive. Which function do I want? The red. So when the red function touches the purple fence, what height am I at? 6. When the green function touches the purple fence, what height am I at? 6. Are they in agreement? Yes. So that limit is 6. They're both approaching 6. Now, what if I had asked you this? What did you say? Does not exist because what is there? There's an open circle. So this means the value. What is the value of x? Sorry, scratch that. When x is 1, what is the value of y? It has no value. It has a limit. It's been stretched to its limit. Cool? I've been pushed to my limit. Cool? You see where that stuff's coming from now? Those phrases? Okay. All right, next one. Okay, that one is not in your packet. Sorry. This is the one you should have, right? And this is called what type of discontinuity? Jump. And my fence is at what number? 2, positive 2. There's my fence, yes? And I have a left and I have a right. Did somebody just say, how did I know where my fence went? Okay, what number am I talking about every time? 2, so that's my fence. Guys, when I do that, I'm not trying to pick on you. I'm trying to get your mind trained into what you should be looking at. I ask questions. I want you guys to solve it on your own. I don't always want to be given the answer, okay? All right, so here we go. Positive means I'm going to look at the right-hand side. So am I looking at red or green? Green. Green touches smack dab right there. How high in the air is it? 1. Great. Now, red touches at a height of 0. Are they in agreement? Does not exist. Now, trick question. Ready? I would like to know, it is 1. Why did you choose 1? There's not a value here, but there is a value here. Cool? Yes. All right. I'm very proud of you. Okay, let me look and see where we're going. So go back to that original paper I told you, limits worksheet 5. It has problems 1, 2, 3, 4, 5, 6, and 17. So that is your classwork/homework. I expect it done for tomorrow.